Okay, when you're doing the slope field for number 1, what you do is you just put in the x coordinate and see what happens. So you can do a little table if that helps you. And let's look at -3, -2, -1, 0, 1, 2, 3. If I plug in -3, my slope is -2. Plug in -2, I get -1. Plug in -1, I get 0. Plug in 0, I get 1. Plug in 1, I get 2, 3, 4. So you have 0 slope when x is -1. So you can draw these horizontal dashes, you know. Then you have -1 slope at -2. They ought to be consistent. And then even steeper at -3. At 0, we have slope of 1. So kind of slanted like this. At 1, a little steeper. And even steeper. And even steeper here. Like almost where they're vertical. You know, you don't have to get too detailed about it, but I mean, just relatively should look steeper. So that's number 1. For number 2, now you're only doing this for y, so there's no x involved. So when y is, we have 5 different y values, -2, -1, 0, 1, 2. So obviously you get -4, -2, 0, 2, and 4. And you're gonna do these not vertically, but horizontally, right? So at y equals 0, you have 0 slope. At y equals 1, we have slope of 2. At y equals 2, you have slope of 4. It's even steeper. Then here, it's slope of -2. It's all relative, you know. And then even steeper here, because you want to show it getting steeper for -2. So just slope field there for that one. Let me actually take a screen grab of this so I can be smart about this here, so I don't have to duplicate my efforts when I'm doing the answer key. Hold on a sec. Just gotta move these boxes here. It just gets kind of annoying. Try it one more time. And save that. Okay, and then for these down here, the slope fields. Now in this case, we'll start with y equals 2. So then it becomes x plus 2. So in that case, when you have -3, it's going to be -1. Then it's going to be 0 here. -1 is going to be 1. And they just keep getting steeper as x increases. That's for y equals 2. For y equals 1, now I put a 1 there, or let's make it look like a 1. So I know at -1 it's going to be 0. But -2 is going to be negative, and even more negative here, and then of course positive, more positive, and so forth. And by the way, just to be consistent, we know that this is, oh, let's go back to red. It's just going to look like that when y equals 0, at x equals 0, dy dx is 0. At y equals -1, x would be positive for dy over dx be 0. At y equals -2, you need x be -2 for dy over dx be 0. And then again, these are just going to be kind of negative. We kind of, kind of expect that now as a trend. And they get more negative in this direction. And of course, they're positive, but more positive in that direction. So there you go. There's a slope field for that one. Here, again, y equals 2, y equals 1, y equals 0, y equals -1, y equals -2. Okay, I'm obviously doing a lot better than I did yesterday because now I've got more practice. If you plug in 2, you get -2 over x. Now it's going to be undefined when x is 0, regardless of what you're doing. So it's going to be undefined, so it's going to be vertical lines here, because that's an undefined slope when you have vertical lines. And likewise at y equals 0, it's just going to be 0 the whole time. don't really do anything. The origin is kind of weird, actually, so maybe I just won't put anything there because 0 of 0 is indeterminate. Anyway, if you do, for y equals 2, if you do when x is 1, I have -2, and then -1, and it gets a little, close to being flat as I go out this way. If I plug in -1 when y is 2, I get +2. And doesn't get quite, it gets a little more flat over here. Yeah, yikes. And you kind of see the same thing. If I plug 1, that's -2, so it's even steeper here. Then -1, then this. Plug in 1, I get negative. So at -1, I get a +2 here. Like that. And it's all reversed here. If y is -1, it actually becomes 1 over x. So when x is 1, that's 1. It gets kind of flat. Or -1, and kind of gets flat. Or if I do x is 2, it's even kind of shallower as a slope. So it's just kind of what you expect for that slope field. And let me take an image of that one. Okay. And then lastly, for these DPQ problems, because I'm going to ask this on the board problem, so I might as well do this with you guys. So solve the following differential equation. So hopefully you see that this is a -x to -2 power dy dx equals that, as well as negative sine x. So when you solve for y, the antiderivative of that is going to be 1 over x, or x to -1 power, because you add 1 to the exponent and divide by a new exponent, but the negatives cancel, so it's just x to -1 power. And that's going to be plus cos x, because 0 cos x is negative sine x, plus c. Then you plug in negative pi over 2, or sorry, 0 for y, and that's 1 over x, so it's 1 over negative pi over 2, plus cosine of pi over 2, plus c. But the thing is that cosine of pi over 2 is 0. That's -2 over pi. Excuse me. So c equals 2 over pi. So your equation is y equals 1 over x plus cos x plus 2 over pi. So let me take that screenshot. That's frustrating. Why does it show that? Okay. And then lastly, for this one right here, y is going to equal, that's 3 secant x. So if you recognize that antiderivative, the antiderivative of ex is ex, and 2x is going to be x squared plus c. Because you, for 2x, you add 1 to the exponent, divide by a new exponent, those cancel, that's why you get x squared. Plug in initial condition, 6 equals 3 secant 0 plus e0 plus 0 squared plus c. 6 equals 3 plus 1 plus 0 plus c. C is going to equal 2. So your equation will be y equals 3 secant x plus e to the x plus x squared plus 2. So that's that one. And let me take an image of that. And put you guys in breakout rooms. Hold on, sorry, just Zoom's being a little stubborn here. There we go. I hope I didn't make a mistake. Someone's putting something in the chat. Hopefully you're just asking a question. If I made a mistake, then I have to do it over again. Oh, did we save the domain? Yeah, don't worry about it. It's fine. Yeah, if you're asking about it. And the question is, number one of the board problems the same as last? Yes, it is. That was intentional because number one of the board problems this week is the same as number one as last week. Last week, we didn't do all of number one, remember? We only did part of it because you hadn't learned the other skills. So yes, I want you to do all number one of the current board problems. So now let me show the board problems right now. Let me clear my drawings. And now I'll post this for worksheet 8. So now that's been done. So if you have textbook problem questions, ask me about that. But you do have those solutions as well, so I'm not too worried about that. Let me leave that open because that's kind of helpful. Let me leave that open. That's helpful. And filled out notes is helpful there. Okay, board problems for today. And I'll create the answer key for that while you guys are working. Let me stop my recording. Nope, hold on.